In section 12.2, we're going to be finding probabilities using permutations. So first, let's define what a permutation is. A permutation is an arrangement of objects in which order is important. So, for example, the 6 possible permutations of the letters A, B, and C are ABC, ACB, BAC, BCA, CAB, and CBA. What this means is these are permutations because they're saying even though we're using the same 3 letters, having ABC and ACB are 2 different things, as well as BAC and BCA and CAB and CBA. So again, even though all 3 letters are being used, they're saying the order in which they are arranged in matters, meaning we have different numbers of possible permutations using those 3 letters. The counting principle is another concept that we're going to be talking about. If there are m ways to do something and n ways to do another thing, then there are m times n ways to do both. So if I was going to say I have 3 pairs of socks and 2 pairs of shoes, I would have 6 different combinations of how I can wear the 3 pairs of socks with the 2 pairs of shoes. So what we're going to do in example number 1 is combine the idea of permutations where order matters with the idea of the counting principle where you just multiply the number of ways to do each thing. So it says, consider the number of permutations of the letters in the word Brighton. Brighton has 8 letters. So in part A, when it says, in how many ways can you arrange all of the letters, we know we're going to have 8 slots to fill with the 8 letters. So I'm just going to first start off by drawing 8 blanks. When I'm considering all the different ways I can arrange the 8 letters in Brighton, I know I have 8 slots to fill, and in our first slot, I would have 8 letters to choose from. So I'd pick a letter. Then in my second slot, I would now only have 7 letters left since I just used that one in the first blank first. So then in my third slot, I would then have 6 since I just used 2 letters in the first 2 blanks. So then in my fourth slot, I'd only have 5, and then 4, and then 3, and then 2, and then in my last blank, I would just have 1 letter left to fill in that 8th slot. So again, with the counting principle, we know that if there are this many ways to fill the first blank, this many ways to fill the second blank, and then the third blank, and the 4th, the 5th, the 6th, the 7th, and the 8th, all I end up doing is multiplying all of these together to figure out how many different ways I can rearrange the 8 letters in Brighton. So I'm going to take 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 to get 40,320 different ways I can rearrange all 8 letters of the word Brighton. For part B, it says, in how many ways can you arrange 2 of the letters? So this time we are going to have 2 blanks to fill. So for our first slot, we would have 8 letters to choose from. And then once we choose that letter, we'd only have 7 letters for our second slot. So I would just multiply those 2 together. So to take those 8 letters and arrange them in just 2 of the letters, I would have 56 ways that I could do that. To take out of the 8 letters and just fill 2 slots, I would have 56 ways. In the last example, we had to take 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and as you saw, it got kind of lengthy. So what a factorial allows us to do is write a shorthand version of doing just that. If I want to take a number and multiply by each number that is 1 less than it, all the way down to 1, you can rewrite that with a factorial, which is basically just an exclamation point. So if I want to take 4 times 3 times 2 times 1, I would write that as 4 factorial, just like that, but with an exclamation point, and it is read as 4 factorial. So if I wanted to take 6 times 5 times 4 times 3 times 2 times 1, I can just write it as 6 factorial, and I would know that means to take 6 times 5 times 4 times 3 times 2 times 1. And most calculators have a key with a factorial. You'll just need to ask me where to find that factorial key so you don't have to type as much into your calculator. we're going to use factorials and the formulas for finding permutations. So instead of doing them the long version like we did in the last example, we're going to find some shortcuts and formulas in order to find permutations more quickly. So the formula for permutations is the number of permutations, so remember that's when order matters, of n objects is given by n p of n, which is basically equivalent to n factorial. So like in that last one when it said we were going to figure out how to rearrange those 8 letters in Brighton in all the ways, so we had 8 slots to fill, we just ended up doing 8 factorial. So again, here's an example. The number of permutations of 4 objects would be 4p of 4, and that is just equivalent to 4 factorial. So you take 4 times 3 times 2 times 1, which is equal to 24. In part B of our last example, we were taking 8 things, but we were only taking 2 at a time. So that's going to be done a little bit differently. So the number of permutations of n objects taken r at a time. So again, in that last example, it was 8 objects taken 2 at a time, where r is less than or equal to n. So r just has to be smaller or equal to how many ever objects you're starting with. And you would write it as np of r, and that's equal to n factorial divided by n minus r, subtract the n minus r first, factorial. So for example, the number of permutations of 4 objects taken 2 at a time is, you would write it as 4p of 2, and that's equal to 4 factorial. So the first number, the number of objects you're starting with, goes on top, 4 factorial. Then you subtract these two numbers and get 2 factorial, since 4 minus 2 is 2. So then if you see how this breaks down, we had 4 times 3, and then we would have 2 factorial left over. So the 2 factorial up here would cancel the 2 factorial down here, leaving us with 4 times 3. So we would have 12 different ways to take 4 objects 2 at a time. Let's see an example of doing this. So here's example number 2. Your band has written 15 songs and plans to record 11 of them for an album. And how many ways can you arrange the songs on the album? So we have 15 objects, taking them 11 at a time. And we would use a permutation for this situation, since putting a song at the beginning of the album would be different than putting the song at the end of the album, because we're trying to figure out how many ways can we arrange the songs where order would matter. So again, we are going to use a permutation. So you would write it as 15p of 11. Using the formula that we saw on the previous slide, we would put 15 factorial on top and 15 minus 11 factorial on the bottom. So to simplify, we would have 15 factorial over 4 factorial, which you can simplify. That would be like 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4. And I'm going to stop there because 4 times 3 times 2 times 1 is equivalent to what we have on the bottom with the 4 factorial. So basically, the 4 factorial up here would cancel with the 4 factorial down here. So I would find my answer by taking 15 times 14 times 13 times 12, 11, 10, 9, 8, 7, 6, 5, multiply all those numbers together to get how many ways they can rearrange the songs on the album. And just as a side note, this is where we're going to end this problem, because when you take 15 times 14 times 13 all the way down to times 5, you actually get a very, very, very large number, so large that your calculator will give it to you in scientific notation and not show you all of the answer. So this was just a bad example that I took out of the book. It would have been more appropriate had they chosen maybe 8 of them that you're choosing, the 15 songs, and you're only choosing 8 of them. We would have maybe gotten a more reasonable answer. So again, the idea is still here. You're going to take how many ever objects you're dealing with, how many at a time. You do the 15 factorial on top like here, and then you subtract the 2 numbers on the bottom and do the factorial, and you'll get the right answer. So let's look at our last example, number 3. For a town parade, you will ride on a float with your soccer team. There are 14 floats in the parade, and their order is chosen at random. Find the probability that your float is first and the float with the school chorus is second. So the first thing we're going to do is figure out the number of possible outcomes of the number of permutations of the 14 floats in the parade. We have 14 floats and 14 positions to fill. So it would be 14 permutation 14 because, again, we have 14 floats that we're choosing out of and 14 slots to fill, which, remember, is just equivalent to 14 factorial. So again, that is the possible outcomes that we can get for all 14 floats. Next, we'll find the number of favorable outcomes where our soccer team is first and our chorus is second. Because remember, probability is the number of favorable outcomes over the total possible outcomes on the bottom. So again, we're going to find the favorable outcomes. So remember, we want our soccer team to be first and the chorus to be second. So that leaves us with 12 other floats to fill 12 positions in the parade. So, and the order would matter. So again, we're going to be using a permutation. So again, we have 12 floats to fill the 12 positions that are left after our soccer team goes first and the chorus goes second. So that would give us 12 factorial. So this is total possible outcomes, and these are our favorable outcomes. So again, when we find probability, we write it as the probability of the soccer team going first and the chorus going second. The favorable outcomes was on top, so 12 factorial. And the possible total outcomes goes on the bottom, which was 14 factorial. So if we think about expanding this, 12 factorial will stay on top, and then we would have 14 times 13 times 12, and then we keep going down, but that would just be 12 factorial. So the number on top, 12 factorial, would cancel with the 12 factorial on the bottom, so we would have 1 over 14 times 13. So 14 times 13 is 182, so I would have 1 over 182, and I would change that to a percent by taking 1 over 182 in my calculator and then moving the decimal point 2 places to the right to get about 0.55%. So again, that means that out of the 14 floats in the parade, in order for your soccer team to go first and the chorus to go second, you would have a 0.55% chance that that would happen. That's it for this section. Make sure you jot down anything that you'd understand that we can cover in class before we move on, and we'll see you then.